thank you again. I'm truly touched and honored by this recognition from my own university. It also made me realize that today I do perceive Aalto as my university. My original science home was the old venerable Helsinki University of Technology, its Department of Engineering Physics, and the world-renowned research environment of the Low Temperature Laboratory. I must admit that I was not really impressed by the initial hype around Aalto University, especially its first quite wavering steps, and how it put an end to my science home. However, Aalto has taken huge strides since then and found its vision, values, and mission. So I think Aalto has evolved, and I have probably evolved with it. Certainly, a scientist has to be willing and able to reevaluate situations and viewpoints when new information becomes available. I suppose my own career path also illustrates that change can be good. I had difficulty in deciding whether to study physics and mathematics or medicine because I was intrigued by the human mind. But I really loved physics and mathematics, and the engineering physics major was also suitably challenging to get into. The stimulating challenges continued, and eventually I found myself defending my PhD in low-temperature physics. I continued to postdoc abroad, but although the field was interesting, its path felt, to me at that time, too well-trodden, and the applications were too far over the horizon. Of course, now, 30 years later, quantum computers are an exciting example of such applications. When the opportunity arose to return to my other passion and join the brain research group in the low-temperature laboratory, I took the risk and made that big jump to try and become a neuroscientist. At that time, in the emerging field of imaging neuroscience, it started to be possible to non-invasively image the whole human brain at once. Everything was a lovely, big challenge, and almost everything was really new. The research groups were multidisciplinary by necessity, and I was well received as a physicist. Of course, changing fields requires a huge amount of work, and you might fail. I didn't want to end up as a dilettante, floating somewhere between fields, so I gave myself 2.5 years to convince myself that I could do it, or else leave academia and do real work elsewhere. And here's where the story starts to sound perhaps a bit like divine intervention, because at the end of that 2.5-year period, we got a paper in Nature on tracking the procession of neural activity during picture naming, and it got quite a bit of publicity. I took that as a sign. If I had fooled Nature's editors and reviewers into thinking that I knew something, maybe it was okay to continue with my passion and hopefully actually become an expert at some point. I continued to dig deeper into the brain organization of language function and its disorders using non-invasive neuroimaging methods. Now, language is such an intriguing human capacity, a key component of our cognition, as well as of the operation of our societies. It's a central part of who we are. Languages are shaped by the world, and in turn, they contribute to how we view and interact with the world. Knowing how our brain makes and uses language could help us figure out how individuals or cultures think similarly or differently, and perhaps help us understand each other better. Frankly, that seems particularly important in these confusing times of controversy. Nowadays, I seem to be generally viewed as a cognitive neuroscientist, but I also still look at neuroscience through the eyes of a physicist. In my experience, research groups formed of truly interdisciplinary people can do really intriguing science. Their knowledge overlaps enough that they can communicate their different perspectives effectively. Advancements in other disciplines can also help with difficult research questions. Sometimes they can make it possible to revisit important questions that were impossible to address and were set aside. 30 years ago, my science father, Olli Lounasmaa, used to say that when we hear a bird singing, see a bird, or read its species name, that information must converge at the same spot in the brain. We all agreed that this was an important research question, but at that time, we didn't have the technical or analytical means to investigate the neurorepresentations of individual items. But now, with advanced machine learning methods becoming an integral part of imaging neuroscience, we can construct and test models of neurorepresentations, computations, and mechanisms that I couldn't have even imagined 10, 15 years ago. And indeed, we are now asking questions that sound a lot like Olli's bird experiment, but of course refined by all the knowledge we have gained in the meantime. It's truly exhilarating to discover something unexpected that changes the way we think about our field, or maybe even about the world more generally. I tend to think that as scientists, we are a little like artists, putting all our passion and heart in our work. We care deeply. So scientists can sometimes get a bit overexcited and forget that what looks too good to be true probably isn't true. In today's academic world, the temptation to demonstrate striking scientific successes is further increased by the severe competition for funding and positions. However, our primary responsibility is to our extended family of fellow researchers, our study subjects, and society at large. It is essential that our universities, as our science homes, fight for an open-minded, respectful, and fair research atmosphere and sufficient research funding. I feel Aalto University is making great strides in that regard as well. As researchers, we are standing on the shoulders of giants, and the next generations of researchers will be standing on our shoulders, whether we are giants or not. Science really is worth fighting for because it is a key ingredient of a civilized human society. And in my mind, first and foremost, because science is beautiful. Thank you.